Hey kids, Flexing Teacher Weber here. Hope you're having a good day. We have been studying the Pythagorean Theorem. We discovered the Pythagorean Theorem by looking at the squares on the sides of right triangles. We've watched some videos on the history of Pythagoras, and we've watched some fun videos on the Pythagorean Theorem, and now we're going to start using the Pythagorean Theorem. So we already know that the Pythagorean Theorem states that the squares of the two legs of the right triangle, so the sides on either side of the right angle, is equal to the square of the hypotenuse. The hypotenuse is the side opposite the right angle. And of course, the right angle is the 90-degree angle, or better described as the L-shaped angle. So when we do this, we're essentially solving a math equation. So in this particular situation, we have a squared plus b squared equals c squared. Or c squared equals a squared plus b squared. And in this case, c squared, we don't know. But we can substitute in our value for a, which is 5 squared, plus the value for b, 12 squared. And then continue working down the page. C squared equals 25 plus 144, and c squared equals 169. But we're not interested in the value of c squared, we're interested in the value of c. So what we have to do is take the square root of both sides. And then c is equal to 13, and in this case we're talking about 13 centimeters. So what you would say then is that the sides of this right triangle, so 5 and 13, 5, 12, and 13 are the sides of the right triangle, and they follow the Pythagorean theorem that the square of this side plus the square of this side equals the square of the hypotenuse. And we call that a Pythagorean triple. Okay, that's how we use the Pythagorean theorem to find the length of the hypotenuse. Let's do a couple more of these. So we'll go on to number 2. We have another right triangle here. We have different variables this time. X equals 9, y equals 12, and we want to find out the value of z. So we can say x squared plus y squared equals z squared, or we can reverse it and we can say z squared equals x squared plus y squared. And then we can substitute in our values. Z squared equals x is 9 squared plus y is 12 squared. And we keep working down the page. Z squared equals 81 for 9 squared plus 144 for 12 squared. And then we keep simplifying that. Z squared equals 81 plus 144 is 225. But we want to know the value of not z squared, but z, so we square root both sides. And when we square root z squared, we get z. And when we square root 225, we get 15, and that's meters. So the length of the hypotenuse, the longest side of this right triangle, is 15 meters. And we would say 9, 12, and 15 are a Pythagorean triple. Let's do one more where we find the hypotenuse of the right triangle. So we have this one here. This time we have no variables assigned, but we know that this is a leg, and this is the hypotenuse. So we could say, okay, x squared, the hypotenuse, is equal to the sum of the squares of the sides. So 5 squared plus 7 squared. And we keep simplifying. X squared equals 25 plus 49. And we'll keep simplifying. X squared equals, okay, I know 20 plus 40 is 60. 5 plus 9 is 14, and 60 plus 14 is 74. Now this time, what's a little bit different here is that we don't have a perfect square, we have an imperfect square. But that's okay. From our previous unit, we know how to estimate those. I know that this perfect square below 74 is 64, and the perfect square above it is 81. So my square root of 74 has to be somewhere between 8 and 9. When I square root both sides, and I've said the kids can use technology for this, this section if they want. Square root of x squared is x. And this time we're not going to have an exact answer, we're going to have an approximate answer. The square root of 74, when we work that out, I believe it's approximately 6.8. I actually reversed my numbers there. I meant to say 8.6. So the square root of 74 is approximately 8 6/10, and that's centimeters. So the length of that hypotenuse is approximately 8 6/10 centimeters. Okay, so in all three of these questions, we were finding the length of the hypotenuse. Let's look at something that's a little bit different now. So these three questions say use the Pythagorean theorem to find the length of the unknown leg. So check this out. The Pythagorean theorem always says the square of one leg plus the square of the other leg is equal to the square of the hypotenuse. This time, we don't know the length of one of the legs. This is a common mistake kids make. They will automatically do this. They'll say f squared equals 6 squared plus 7 squared. But that's not what the Pythagorean theorem says. The Pythagorean theorem says this leg squared plus this leg squared equals the hypotenuse squared. So the way we're going to want to write it in this case is not that. We're going to write it as, okay, f squared, we don't know what f is, plus the value of e squared, which is 6 squared, equals the hypotenuse squared. In this case, the hypotenuse is the variable d, and we know that that's 7, so 7 squared. Now check it out. We have a bit of a different math equation here, but we're still going to use order of operations to solve it. F squared plus 6 squared is 36 equals 49. Now, what we want to do in this math equation is we still want to figure out the value of f squared. So to simplify this, we need to make the positive 36 disappear and turn into 0. The way we can do that is to subtract 36 from that side of the equal sign. And if we subtract 36 from this side of the equal sign, we have to do the same thing over here to keep balance in the equation. So we have to subtract 36 from 49. When I work that out, I get f squared on that side of the equal sign, because the positive 36 and negative 36 go away, equals 13. And now, to figure out the value of f, I square root both sides of the equal sign, and I get f is equal to the square root of 13, and the square root of 13 is approximately 3 6/10. And I should write that properly, so use the approximate symbol because it's not an exact answer. Square root of 13 is approximately 3 6/10 centimeters. We could also estimate that, right? We know that the square root of 9 is 3, and the square root of 16 is 4. So the square root of 13 has to be somewhere between 3 and 4. Okay, let's look at another one. Again, we have to identify what we're trying to find here. Now, the Pythagorean theorem says that one leg squared plus the other leg squared equals hypotenuse squared. So in this case, x squared plus 10 squared equals 14 squared. It's always the square of one leg plus the square of the other leg equals the square of the hypotenuse. And remember, how can we find the hypotenuse? It's always opposite, the side opposite the right angle, or the L-shaped angle. Okay, start solving your math equation. X squared plus 10 squared is 100. equals 14 squared, which is 196. Okay, we want to figure out what x squared is, so we need to make positive 100 disappear or go away. We do that by subtracting 100 from that side of the equal sign. And to keep balance in the equation, we do the same thing to the other side. So you got to subtract 100 from both sides. The equation now simplifies to x squared equals 96. And now we want to figure out the value of x, so we square root both sides. And square root of x squared is x. And the square root of 96 is approximately, well, we know the square root of 100 is 10, so the square root of 96 is going to have to be a little below 10. So the square root of 96 is approximately 9 79/100. We can round that off to 9 8/10 centimeters. And that's the length of that leg. So that's how we can use the Pythagorean theorem to find the length of a leg. Let's just do one last question. Sometimes the triangles might be in a weird position, but you still have to look at what you have here. In this case, here's my right angle. So that means Z is the hypotenuse, and the two legs are on either side of the right triangle, or the right angle, pardon me. So to solve this, we know we're missing a leg because we know the value of the hypotenuse. The Pythagorean theorem here is basically x squared plus y squared equals z squared. So, x squared plus y squared equals z squared. Okay, in this case, x is 3, so 3 squared plus y squared equals z is 8, so 8 squared. Now, if you wanted, you could say y squared plus 3 squared equals 8 squared. It's the same thing, but I'm going to do it like this because it's good that we see these equations written a little bit differently sometimes. Okay, 3 squared is 9 plus y squared equals 64. Now, it's the same thing as before. We want to know the value of y. So we have to start simplifying this by making the positive 9 disappear. I can do that by subtracting 9 on that side of the equal sign. And if I subtract 9 there, I have to subtract 9 on the other side of the equal sign. Now what we're left with is this positive 9 and minus 9 disappear, and I'm left with a positive y squared. I can just write that as y squared equals 64 minus 9 is 55. We want to know the value of y. So I square root that side, square root that side. And y is equal to whatever the square root of 55 is. Now, 49 is a perfect square, its square root is 7. 64 is a perfect square, its square root is 8. So this answer has to be between 7 and 8. You can use your technology, and the square root of 55 is approximately 7 4/10. Always forget to do that. I want to use the approximate symbol here. It's not the end of the world if you don't, but we'll say 7 4/10, and in this case it's centimeters. So we've calculated the missing side of that right triangle. I should say that most of these drawings I have in these notes aren't drawn to scale, so sometimes the sides look weird, right? Like 7 4/10 is much larger than 3 centimeters, but they look exactly the same. So that's your teacher being a little bit lazy there. I should get a little on, make those diagrams a little more accurate. But hopefully that helps you understand the Pythagorean theorem. There's 2 things you need to be able to do. The first thing is you need to be able to find the length of the hypotenuse, like we did in the first 3 questions. And then the second thing you need to be able to do is find the length of a missing leg, like we did in the last 3 questions. That will help you with your assignment today. I hope that helps. That's all for now. Flexing Teacher Weber, out.